Disclaimer: this video is not mine, credits the real owner. Water bodies, natural and built environment, and related sociological systems such as policy and governance have experienced significant impact from the economic slowdown resulting from the COVID-19 pandemic. While human health and life are our primary and immediate concerns to address, water and pollutions from local to regional scales have seen discernible positive impacts due to reduction of pollutant loading from industries, vehicle emission, and other sources. Anecdotal evidence indicates that a reduction in biochemical oxygen demand and coliform levels in rivers, improvement in air quality as a result of reduction in the loading of nitrous oxide, particulate matter, and other pollutants. The extent of recovery seen would not have been possible without extreme measures that have been forced on the society due to the pandemic. At the cost of several trillions of dollars across the globe, this enormous and unintended experiment offered opportunities for the unprecedented insights about the dynamics of our natural and built environment and societal systems that can lead to feasible paths for preservation of recovered systems and new recovery pathways through sensible policies and practices. The goal of special collection is to develop insights into link between human activities and impact on water and the pollution and build and sociological human systems, both during the recovery of the natural systems during the pandemic and possible subsequent degradation pathways as economic activities pick up, including assessments of niche habits that may provide long residence times for the virus and or adverse impacts on ecosystems. The rapid transient response presents an opportunity to capture the behavior of large, degraded, vulnerable but society valuable systems, both during the recovery and subsequent degradation, develop insights leading to hypotheses, theories, and predictive models documented through compiling case studies and supporting data sets. Both direct and indirect impacts are possible. Direct impacts include water quality improvement owing to reduced industrial effluents, while indirect impacts include changes in urban climate or land atmosphere interactions owing to reduction in atmospheric pollution. Opportunities for assessing the cost of consequences of existing policies and practices and development of alternative effects policies to preserve the recovered systems or guide systems for recovery, mitigate adverse impacts, or enhance resilience are also possible. This special section invites the following submission types: original. Human life comes to a standstill as many countries shut themselves off from the work due to novel coronavirus disease that hit the world severely in the first quarter of 2020. All types of industries, vehicle movement, and people's activity suddenly halted. Perhaps for the first time in modern history, for a long time it has been stated in various literature that the increase in industrialization and anthropogenic activities in the last 2 decades polluted the atmosphere, hydrosphere, and biosphere. Since the industries and people activities have been shut off for a month or more in many parts of the world, it is expected to show some improvement in prevailing conditions in the aforementioned spheres of environment. Here, with the help of remote sensing images, this work qualitatively demonstrates the improvement of surface water quality in terms of suspended particulate matter. Face coverings are now legal requirement in many public spaces around the world, but even before they become compulsory, masks were causing litter problems on land and at sea. Despite millions of people being told to use face masks, little guidance has been given on how to dispose of or recycle them safely. And as countries begin to lift lockdown restrictions, billions of masks will be needed each month globally. Without better disposal practices, an environmental disaster is looming. The majority of masks are manufactured from long-lasting plastics, and if disregarded, can be perish in the environment for decades to hundreds of years. This means they can have a number of impacts on the environment. Initially, disregarded masks may risk spreading coronavirus to waste collectors, litter pickers, or members of the public who first come across the litter. We know that it is in certain conditions, the virus can survive on plastic surgical masks for 7 days. Over the medium to long term, animals and plants are also affected. Through its sheer mass, plastic waste can smother environments and break up ecosystems. Some animals also cannot tell the difference between plastic items and their prey, subsequently choking on pieces of litter. Even if they do not choke, animals can become malnourished as some materials fill up their stomachs but provide no nutrients. Smaller animals may also become entangled with the elastic within the mask or within gloves as they begin to break apart. Plastics break down into smaller pieces over time, and the longer litter is in the environment, the more it will decompose. Plastics first break down into microplastics and eventually into even smaller nanoplastics. These tiny particles and fibers are often long lived polymers that can accumulate in food chains. Just one mask can produce millions of particles, each with the potential to also carry chemicals and bacteria up the food chain and potentially even into humans. Littered areas also tend to encourage further littering, making the problem worse. In March, the World Health Organization estimated that 89 million additional disposable masks were needed globally per month in medical settings to combat COVID 19. In addition, a recent working paper by the Plastic Waste Innovation Hub at University College London has put the current domestic demand for the UK at 24.7 billion masks a year. However, the demand for domestic face masks in the UK drops dramatically to around 136 million a year if only reusable masks are used. But even with reusable masks, their specific design and how to choose to clean them makes a difference. The University College London team explained the manufacture, use, and disposal of masks that were disposable, reusable, and disposable filters to calculate their overall environmental impact. They found washing machines reusable masks with no filters had the lowest impact over a year. Hope you guys learned something from our discussion for today. Goodbye for now and don't forget to subscribe to my videos.